Well, I am back for the exam one review, or not review, going back over what I did wrong. I don't know why the first part of the video I just recorded did not go through, so I'm just going to go ahead and kind of explain what I did wrong here. So looking at our equation here, y equals 3x plus 5. Y has already been solved, so I just needed to plug it in. I'm going to use the substitution method, so I'm going to plug it into the 5x minus 2y, and that's what I've done here. Taking a look at what I did up here, I can instantly tell you what I had done wrong was negative 2 times 5 is not a positive 10 as I had up on my original answer. It was negative 10, so it was negative x minus 10 equals negative 7. Then I needed to add 10 to both sides of the equation to get negative x equals 3, and to divide by negative 1 to get negative 3, since we need to have the variable as a positive, not a negative. So that is why I got that part wrong. So then substituting x for negative 3, I go back to y, my y equation that was already solved. So then that's y equals 3 times negative 3 plus 5. So then that gave me y equals negative 9 plus 5, combined like terms. Y equals negative 4, so then the final answer in set builder notation is going to be a parenthesis, negative 3 as x and negative 4 as y. So that's all I've got for that. Like I said, that's where I went wrong, was doing my order of operation, not my order of operations, my distributive property wrong. Alright, so for 2b is what I had got wrong. It asked to write the domain of the function in interval notation. That one now looking at it, I just read it completely wrong. The key word here is domain, not finding f of negative 3, which I had negative 1 over 5. So the domain for our function here is 2. So then, writing this in interval notation, I'm first going to do a line graph. I'm going to go by negative 2, 1, 0, or sorry, negative 1, 0, positive 1, positive 2. So the reason why this is 2 is because it's only possible when any denominator is greater than 2. So, since it cannot be divided by 0, and divided by 1 makes the number whole. So when we have 1 over x minus 2, 2 will work for our domain here, as I just mentioned before with the rule. So with that being said, with a domain... Sorry, I keep having a frog in my throat tonight. So with our domain, what that means is anything that can equal to 0 is our intended goal, is what can equal to 0, whether it's a negative or if it's a positive. So with this, it's pretty simple. Even if it's negative 2, if our domain was negative 2, all it takes is 2 spaces over on our number line to get to 0. Same with the opposite direction. If our domain is positive 2, which it is in our equation here, we just go back 2 spaces. So it's only by 2 spaces on our number line that we get to 0 and make it 0. So with that being the case, I'm going to put a point on our negative 2 and 2. So for our interval notation, we're just going to put a parenthesis, and then we're going to fill out here to positive 2. So then we're going to write this as negative infinity 2, and then positive 2 to infinity positive. But we're going to put u here because this is our union. So what this is saying is that negative 2 or positive 2 is our answer for this for the domain, and then this is being wrote out in interval notation. And with our u, it satisfies any value of the inequality. Alright, for the next one that I got wrong was 3a, and this, once again, I just did not read this the right way that I should have. So I'm going to write this as GA plus B equals to negative 5. And the way I put it was negative 5, which was, or 5x, which is not the case because we are substituting. X is just our variable that we just put in there. It doesn't exactly mean that it has to be x. For our case, we needed to substitute a plus b, as it stated here, when g of x is g times a plus b. So I'm going to go ahead and plug that in. A plus b plus 7. So then now, just following on the distributive property, a plus b is going to be negative 5a, since negative 5 times a is negative 5a, minus 5b, negative 5 times b is 5b, plus 7, and that is a small, that's the lowest we can go. We cannot go any lower than that because we don't have any, like, either variables or numbers, so that's all we've got for that. So for, once again, I just did not substitute properly here on 3a. So for 3b, I did the opposite. I thought I was supposed to be substituting when I was not. I was just solving for x. So I'm going to go ahead and rewrite my equation here. So for g of x equals to 2, it's going to be 2 equals negative 5x plus 7. So instead of substituting like I thought I did, I just need to solve for x. So to do that, since we have our equal sign here, I need to subtract 7 from both sides here. That's going to give me negative 5 equals negative 5x. And then to solve for x, we're going to divide by negative 5. And that's going to give us as x equals to positive 1. So just to kind of reiterate, for 3a, I did not substitute properly when I should have. And for b, I did not solve for x, which that was our key term here, was find all values, or value for this equation, which was the key term to solve, not to substitute. So that's what I did wrong with that one. So for number 4, since I got the first part of it wrong by not properly writing the equation in slope-intercept form, that's why the rest of it was completely wrong. Looking back on it, I'll kind of just point up here to where I have, and I'll kind of point with my mouse. Here, what I did wrong here, and I don't know why I just overlooked it. I must have not gotten much sleep the night before. So this negative 4 divided by y, so divided by negative 4, that does give me y. However, over here, 8 divided by negative 4 is not a positive 8. I don't know why I thought that was the case. It should have been negative 2. So I'm just going to go ahead and rewrite this out here. Alright, so then with this being the case, I need to subtract x from both sides. That gives me negative 4y equals negative x plus 8. Same deal, I'm going to divide by negative 4. And so that's going to give me y equals 1 over 4x minus 2. With that being the case, the other part that I did wrong is I did not carry over the 1, because with x, even though it's by itself as a variable, it still counts as 1. And this is kind of one of the things with algebra that kind of throws me off a lot, is even though x is a letter and it's a variable, in this case it still can be added into our equations and substituted and whatnot. So instead of just having it as 4, as I put up on the top here, 4x, it's just 1 over 4. So that is my slope-intercept form. So that's going to be number A. Or, yeah, writing it in slope-intercept form. B asks us to find slope, which is 1 over 4. Pretty simple and straightforward with that one. C asks us to find the x-intercept and to write the answer as the ordered pair. So I'm going to go over to my graph here. I've already kind of plotted some of it out, but I'll do it again here just to show you. So we're going to go over 8 spaces since it is positive, and we find that there. Okay, sorry, I had to look at my answer here and figure out what I was talking about there for a second. So actually for C, I'm going to skip that for right now because I need to plot my y-intercept first. So looking at C, my y-intercept is negative 2. So for my first ordered pair is going to be 0 and negative 2. I'm going to go over here to my graph here, and I'm going to go down 2 spots to negative 2. And so this is what I was talking about earlier that I had already kind of plotted it out, but I'm still going to show you. So then to find my x-intercept, I need to use my my slope here and use the rise over run method, or r over r. So what I mean by that is I'm going to go up 1 since it's positive 1, and then to the right 4. So rise and then run. So that's going to be up 1, then 1, 2, 3, 4, and then up 1, and then 1, 2, 3, 4. I'm going to place those 2 points here just to show you there. So then my x-intercept, the first x-intercept is going to be 8 over 0. And then I'm going back to our original -2. I'm going to then go the opposite direction, so rise and run still, but instead of positive, it's going to be negative. So we're going to go down 1 to make it -1, and then to the left 4. And then just one more time for kicks and giggles. And then let me draw my line real quick. So sorry my line isn't straight. My makeshift ruler, which was a note card, decided to kind of give out there. So to look at 2 points here, I can also use what I had over here, but just to be all fair and everything, I'm going to write, for this point, I'm going to just circle it here. Going to be -1 on my y-axis, and that's going to be +4, and then of course, like I said, 0 and then 8, and then for my middle one here is going to be 0, -2, and then 2, 3, 4, -3, and then for my last one here is going to be, it's going to be -8 and -4. So I've plotted all my points here, and that is like I said, what I did wrong here is I just did not write slope intercept correctly, and then that's why everything was all half backwards there. So all right, so for this one, I did the same thing as I did on, what was it, problem B. Is I can kind of show you here with my mouse pointer. There we go. Right here is when I was solving for y, or I'm moving it into slope intercept form, sorry. I had to divide it by -1, and a 2 divided by -1 is not a +2, it's a -2. So when I did that, that's when it threw everything off. So I'm going to go ahead and just rewrite out everything real quick. So x minus y equals 2. I need to solve for y, so then I'm going to subtract, or not solve for y. I need to write in slope intercept form. Let's try that again. So that's going to be -y equals -x plus 2 divided by -1, because we need to get the variable y by itself. So that's going to give me y equals x minus 2. That's what I did wrong there. So then now I'm going to plug it into my bottom equation here, the -2x plus 2 times x minus 2 equals -4. And then carry out my distributions. -2x, 2 times x is going to be 2x. 2 times -2 instead of +2 is going to be -4, and then equals -4. So with that being the case, that right there, -2x and 2x, take care of itself. So that gives me -4 equals -4. And that's going to get equal to infinite solutions, because that is the case. So what that also means is it's going to be on one line, not 2 lines. So then my slope here, going back to my slope intercept form, is going to be 1 over 1, or technically it's x, but I'm going to put it 1 over 1 so I can actually draw it on, or put it on here. My b-intercept is going to, or my y-intercept is going to be -2. So I'm going to start off with that, -2. And then once again, I'm going to use rise and run. So up 1 over 1, up 1 over 1, up 1 over 1. And I can just keep going on until I graph it completely. And then I can do the same going backwards. So I show you here what I'm doing. So all these points is what can equal when y equals x minus 2. So once again, I apologize. My line or my graph is not going to be drawn out straight with the ruler. Just for all intents and purposes, I'm just showing you what I did wrong there. It was not properly evaluating correctly when it came to, like, once again over here, my 2 divided by 1, it was not +2, it was -2. That's why I had a completely different graph and everything. So with that being the case, that is what I got for 5. So then going back to 6a for what I got wrong here, I had to go back and reread a lot of stuff. I just got that wrong. There's not much. I just read it wrong, and I forgot the rule. And this is false because the denominator is 1. Since our denominator is x technically, but it's still considered 1. And with that being the case, dividing it by 1 makes it a whole number. So with f of x equals 1 divided by 1, that equals to f of x equals 1. So that's false. We can't do that. Well, sorry, I shouldn't say we can't do that, but the domain is not 1. It has to be greater than 2 for it to divide properly. So that's what I got for that one. And for B, I got that wrong again. False. Because x equals 7 is not a function. Once again, I had to kind of go back and reread some stuff and find out why it was false. Because graphically, if we put it on that line here, I'm going to jump back to my graph here. So I put it here as x of 7, so 1, 2, 3, 4, 5, 6, 7. Say I just put it there. It's just going to be a line up, straight, and down. There is no slope. There is no y-intercept. So with that being the case, slope's undefined. So it's not a function. There is no input to get an output. There is no domain to get a function. It's just, no, that's just wrong. So then going on to the next problem that I got wrong, it was 9a. I have not been able to figure out why you got y equals 2.25. I will email you separately just so you can probably email me back of why you got that, just so I can kind of keep that for future note. I tried moving the graph over with -1 as the input for x, and I got something still completely different, so I'm just going to go ahead and just take the point off for that, because I still don't know what that is. I don't know why you got y equals 2.25. So I know you said from our email that I sent you earlier, not that I had both gotten 11C and D wrong, but just to go ahead and put down for part D, just to, I guess prove myself that I, once I went back, I actually figured out what was going on. I'll go ahead and just do C again, just to show you here. What I did not do right is I did not subtract from the inequality to get both parts. I just did the first part, and that's why I got 5 and not -3. So with that being the case, the absolute value of x minus 1 is less than 4. We're going to have +1 to get x by itself. So x is less than 5. And then now on the opposite end, which this is what I did not do, the absolute value of x minus 1, not greater than, less than, -4, so +1 on both sides. X is less than -3, and then putting that interval notation would be -3 over 5. So I just didn't do the second half of it. And then I take that back. Actually, it was number D that you wanted me to do, not E. So I still needed to do C. So I did C. So then going back to D here. So then with D, I did the same thing as I did with C. I did not do both the addition and the subtraction. So I'm going to start off with the addition. So it's going to be the absolute value of 3x plus 4 plus 2 is greater than or equal to 8. And then combine like terms is greater than 8. And then I'm going to subtract 6 from both sides. That's going to give me 3x is greater than or equal to 2. And then divided by 3 is going to give me x is greater than or equal to 2/3, because we cannot simplify that anymore. And then for the second part, I need to subtract 8. So 3x plus 4 plus 2 is greater than or equal to -8. Once again, combine like terms. So then subtract 6 this time. That's going to give us -14. And then divided by 3, it gives me x is greater than or equal to -14/3. With yours, you had put -10/3. I'm not certain. I don't know if I did something else wrong. I checked this several times. I also used some calculators online that I was able to find, and this is still what I got. So, I don't know. Maybe I'm just doing something wrong the way I shouldn't be, or not, but just to kind of move forward here, because I can't keep, I don't want to say wasting too much time, but I can't keep holding back and trying to figure this out. So then my final set builder notation is going to be -infinity to -10/3. We're going to put a bracket there. Here, I'm going to do it down here. -infinity, -10/3 bracket. Since this is inequality, so this means or 2/3 to +infinity. And that's my final answer for that. And alright, that's what I've got for my exam 1. I'm going back over the problems that I did wrong, so I will see you for the next recording video.